Welcome everyone to our class. We are going to be continuing with our forces topic. And the forces, we are going to do motion of connected bodies today. Now let us consider two bodies. So let's say I have two bodies of mass m1 and then I have another body of mass m2. So what I want to do is that I want to connect these two bodies, connect over a light inextensible string, and then I'm going to pass the bodies or pass the string, so pass over a very smooth pulley. Okay, so if this is representing my pulley, then I'm going to have this to be my light inextensible string. This is my mass m1 and this is my mass m2. Good. Now once you have this diagram and you have this masses, then it means that there is going to be movement either to the left this way or to the right, depending on the masses. So assuming m2 is greater than m1, then we can derive a lot of equations to indicate how to be able to calculate for the acceleration of movement and also for the tension. I'm going to just do a little illustration on this here. Now, once the string is one string attached to mass m1 and attached to mass m2, what it means is that one, the tension is the same, and two, acceleration is the same. So we can say that the tension is the same and then the acceleration is the same. I'm going to draw the diagram again here. Let me just draw the diagram again. This is my mass m1 and then this is my mass m2. This is my pulley. Now, the things that I want you to take note is that if we take this mass into consideration, you realize that it will always exert a weight downwards. So let me call it m1, which is equal to m1g, and then it will have a tension which is upward. This other mass will also have its own weight m2g, and then it will have a tension upward. Now, this is T and this is T because I've already talked about the fact that the tension is the same throughout. Good. Now, the reaction is also going to be on top here. So we can have our reaction R over here. From the diagram, the reaction R is going to be W1 plus W2. But you can see from the whole diagram again that W1 is equal to T and W2 is also equal to T. So it implies that our reaction is equal to T plus what? T, which is equal to 2T. So we can say that from this whole thing, our reaction R is equal to 2T. That is the expression that we can have for the reaction. The next thing that I would want us to derive from this diagram is also the acceleration and the tension. Okay, now with the acceleration, let me just quickly draw the diagram again so that we can deal with acceleration. So I have m1, then I have m2, I have weight which is m1j, then I have weight which is equal to m2j. This is weight 2, this is the tension is T here, the tension is T here. Now the acceleration can be derived based on the direction. So if, or assuming m2 is greater than m1, what happens here is that there is going to be movement in this direction. So there's going to be acceleration in this direction. Okay, so this will be the direction of movement. Good. Now, because we have two masses, m1 and m2, it indicates or it shows that the tension or the masses can be calculated for two different sides. So the masses is giving us a resultant force in two different sides. So if we consider M1, if we consider the mass M1, we can say that the resultant force, that is the force of resultant here, is M1A. That is the movement or the resultant force due to M1. And this resultant force here is as a result of the two forces, the tension and then the weight. Okay, so from here we can say that the resultant force F of R is equal to, we can use the direction, or we are going to be using the direction of movement. The tension is upward this way, and this is the direction of motion. So it implies that the tension is moving with the direction of motion. So the tension will be positive, so plus T. Then plus the weight. The weight here is moving opposite to the direction of motion. The motion is this way and the weight is downward. So it's going to be plus negative W. So if I want to rewrite this equation, I'm going to get M1A is equal to T minus M1J. Let's call this equation 1. Good. Now, if we consider M2, M2 will also have its own resultant force, which is equal to M2A. So M2A, or let's just do the resultant force here is going to be, you see that here the tension is in opposite direction to the movement. So it's going to be minus T plus the weight is in the same direction. So we have M2J. So finally, we can say that M2A is equal to negative T plus M2J. This here is the same as the weight, so you can even write W2 here before you come and replace it with this equation. So let's call this equation 2. Now, we want to solve equation 1 and 2. So solving equation 1 and 2, we have M1A is equal to T minus M1J. And then we have M2A is equal to negative T plus M2J. So if you want to solve this, you can add here. If you add, you would have A out, M2 plus M1. Then this is positive, this is negative. So it will go away. So the tension goes away over there. Then we can have J out, M2 minus M1 this way. So that our acceleration A becomes M2 minus M1 all over M2 plus M1 multiplying J. This is how you could be able, or you should be able to get the acceleration. Now, once you are able to get the acceleration, you will fix this acceleration into any of the equations for the tension. So you come and arrive at the tension T to be equal to 2 M1 M2 all over M2 plus M1 multiplying J. This is how you should be able, or you'll be arriving at your acceleration and then your tension. So here we are basically focused on 3 equations. The first one is the acceleration, the second one is the tension, and then the third one is the reaction, which is equal to 2 multiplying T. Okay, we would have to solve a few questions in our next class so that we can get the attention, or better still, let us just try one question here and then see how to apply these ones. Okay, so let us look at the question on the board. We have 2 particles of masses 4 kilogram and 2 kilogram hang freely on a light inextensible string passing over a smooth pulley. Calculate the acceleration, the tension, and then the reaction. So in our solution, I have my first mass. So let me make this 2 kilogram and then let me make this 4 kilogram. I have my weight W1, which is equal to 2 times 10. I have W2, which is also equal to 4 times 10. So the weight here is 20 Newton, and the weight here is also 40 Newton. I have my tension here, I have my tension here. Okay, good. Now, if we want to considering the 2 kilogram, so let's call this M1. So considering M1, which is equal to 2 kilogram, we can say that M1A is equal to, the tension is moving. Since this is greater, so the direction is this, since this is 4 and this is 2. Okay, and the tension is moving in the same direction. So it's going to be T minus M1J. So we can finally say that since M1 is 2, so 2A is equal to T minus 20. Let's call this equation 1. Good. Now, when we consider M2. When we consider M2, we can also say that M2A is equal to minus T plus M2J. If you do it this way, then you are going to get 4A to be equal to minus T plus 4T, equation 2. So when we want to solve equation 1 and 2 simultaneously, we have this, and then we have 2A is equal to T minus 20. If we add, you are going to get 6A is equal to 0, then 40 minus this plus 20. So A is 20 all over 6. So 20 divided by 6 is going to give you 10 over 3, or 3.33 meters per second squared. This is what you are going to be getting for your acceleration. So after getting acceleration, you can then come and fix the acceleration into any of the equations. So from equation 1, we can say that 2 multiplying 3.33 is equal to T minus 20. So T is equal to 20 plus, this is 6.66. So T becomes equal to 26.66 Newton. So this is how you are going to arrive at your tension. And then remember the reaction. So the second one, the reaction is R is equal to 2 multiplying T. So the reaction becomes 2 multiplying the tension. So you have 2 times 26.66, and that is going to give you 53.32 Newton. So you have your tension, you have your reaction, you have your tension, and then you can also have your acceleration. You can solve the question this way, or better still, you can use the equations to solve the question. Let us try it with the equations that we have and then see what we will arrive at also. Okay, now let us try with the equations also. So your solution, if you think that you can keep the equation, then the first one, the A aspect of the equation, acceleration. So let's substitute M2, our mass 2 is 4, our mass is 1 is 2, all over 4 plus 2 times 10. So this is 2 over 6 times 10. This is equal to 10, 20 over 6, which is the same as 10 over 3. So this is going to give us 3.33 meters per second squared for our acceleration. Then our tension to T is equal to 2 times 4, all over 2 plus 4, or 4 plus 2 times 10. This is the same as 2 times 2, 4, 4 times 4, 16, 160 all over 6. 160 over 6, this will give you 6.667 or 0.67. Let's make it 0.67 Newton. So the tension R becomes equal to 2 multiplying T. Therefore, the reaction R becomes 2T. Therefore, the reaction becomes 6.67 multiplying 2. This is equal to 53.32 Newton. This is how you can arrive at your answer. You can do this in so many ways. This is the first way. Thanks very much for joining us in our class. I hope this has been an improvement of our recording so far. Please sign up to my work, subscribe to my channel, watch the videos or the subsequent videos that we would have for you. There is always going to be a new thing, an exciting thing. Thank you very much, and thanks for watching. Bye-bye.